Alright, so today what we'll be doing is finding the slope of tangent lines to some sort of function. So here's our example. We're going to first graph y equals x squared. Here's a picture of it over here. And we're going to try to find the slope at the point x equals 1. So over here is x equals 1 on the x-axis. If I go up, then that point right there is the point 1, 1. And that's where we're going to find the slope. So what we should do in our minds is kind of estimate what we think that slope will be. It looks like it's for sure going to be a positive slope, although I don't know quite how steep yet. And we are going to need our slope formula, so here it is. y2 minus y1 over x2 minus x1, or the rise over the run. Now usually we need 2 points to do this, but we are only given 1 point, so we're actually going to manufacture our second point. So over here on our graph, you've got the point A, which is 1, 1, and I actually have had GeoGebra graph this line right here so that it is a true tangent line. Now looking at the graph, you should be able to count that the slope is up 2 over 1. So the slope of that line is 2. We're going to see if we can get that algebraically, because it's not always going to be as easy as that. So in order to do that, we need a point. Our point's going to be 1, 1. And then we need a second point, so we're going to have to figure out what second point we're going to use. So we're going to use the point 1 plus h as our x value. And the reason we're going to do that is because we want to actually make a secant line using the point 1, 1 and a point really, really close to 1, 1. And then at the end, what we're going to do is slide that point closer and closer to 1, 1 so that we can get an even more precise version of the slope. And so what we're going to use is the point 1 plus h, which is our x value. And to get y values, if I know an x value, I plug that point into our function. And so if you remember back, our function is y equals x squared. So we have the point 1, 1. And then our x value on our second point is 1 plus h. And our y value on for our second point is 1 plus h quantity squared. So then we're going to use our slope formula. Now don't forget that our slope formula is y2 minus y1. So 1 minus 1 plus h squared, that's the y value on our point that we manufactured, over x2 minus x1. 1 plus h was the point that we manufactured, the x value of it. And so what we're going to do is do some algebra here. So the next step that we have done is to multiply out that 1 plus h quantity squared, which gives you 1 plus 2h plus h squared in there. The 1 minus is still in the beginning. And then we distributed our minus sign here to the 1 and to the h, giving us 1 minus h. And then you should notice that this 1 minus 1, that is 0. 1 minus 1 is 0, giving us a negative h on the bottom. On the top, we distributed the negative sign. So we have 1 minus 2h minus h squared. Again, we're going to get rid of our 1's because 1 minus 1 is 0, leaving us with this expression here. And then the next step would be to factor out a negative h. I noticed that the top shares a common factor, which is negative h, so I'm going to factor it out, leaving you with 2 plus h on the top. If you notice, these negative h over negative h divide to be 1, and you're left with 2 plus h. That is the key to what we will be doing next. There's our graph again, just to remind you. And now we have an expression for the slope between the point 1, 1 and a slope of h distance away from 1. So now our job is to shimmy that little point right close to A. And what we essentially are going to do is we want h to be 0. We want the difference between this point and the point that we made up to be 0, so that they're essentially on top of each other. So that is, we need a limit to do that. So we're going to take the limit as h approaches 0 in this expression right here, which at this point you should know that we do that by just plugging 0 in for h into that expression, which gives us that the slope at 1, 1 is 2, which is what we estimated it to be in the first place. And that is how you estimate slopes of tangent lines.